Hey, boys and girls, welcome to Mrs. Walker's sixth grade virtual science classroom. And today, the standard that we are going to focus on is the Earth Science Standard 6.8.3, Evaluate Modern Techniques Used to Explore Our Solar System's Position in the Universe. So, space exploration. When I think of space exploration, two things come to mind. The first one is NASA, which is a government-run body. It's nonprofit, paid for by our tax dollars. It's been around for quite some time, and then we also have SpaceX, which is privately owned. It is for profit, and it's maybe a little more cutting edge. It's a little bit newer. However, these two organizations have a mutually beneficial relationship and they work together. They don't compete against one another. NASA depends on SpaceX and SpaceX depends on NASA. And so they have a really great working relationship, which I think is absolutely needed to be successful with space exploration. So the way that we explore space is a few different options. Earth-based observations is the first one we will discuss, then airborne and orbital telescopes. Then we have probes and flyby spacecrafts, orbiters, landers, and rovers. So the first one we're going to talk about is the Earth-based observations. When you think of Earth-based, you should be thinking of how we view space from the Earth. And so we're going to start with telescopes. And there are various sizes and strengths of telescopes. The first person who gets credit for creating or building the telescope is actually kind of controversial from the 1600s. There's a few different individuals who applied for patents who were doing similar things. And if I remember correctly, they were actually both denied their patents because of the simplicity and the easy ability to replicate. So there's some interesting history behind telescopes, but they've been around since the 1600s. And then we have radar astronomy, and radar astronomy was born in 1946. And this is where you have radio signals that are sent from the Earth out, and then they bounce back. And we were first able to reflect them off of the moon and then off of Venus. And then they were able to actually map out the surface of Venus in 1988 and do a little more research that way. And then we have radio astronomy, which is a type of a radar astronomy, actually. Radio astronomy is the study of celestial objects that give off radio waves. With radio astronomy, we study astronomical phenomena that are often invisible or hidden in other portions of the electromagnetic spectrum. So the radar astronomy bounces off of specific solid objects, and radio astronomy, it's kind of reaching out in areas that we're not quite sure if it's a solid, if it's a mass, if it's a ball of gas and dust, things like that. All right, then we have our airborne and orbital telescopes. So I have two pictures here on the left. The Stratospheric Observatory for Infrared Astronomy, also known as SOFIA, is a telescope carried on top of this Boeing 747 airplane. And the airplane can fly at an altitude of 12 kilometers or 7 miles or more above 99% of Earth's atmospheric water vapor. And this allows SOFIA to make observations in infrared wavelengths that are absorbed by the atmosphere at lower altitudes. So SOFIA can carry scientists, crew members, educators, students in a pressurized cabin with the telescope to do some more research and exploration. And then we have Hubble. And Hubble has been around for 30 years. It was originally put into space with the intentions of lasting 15 years, and it has definitely superseded that. But the Hubble Space Telescope was the first in a series of orbital telescopes to study the evolution of the universe. The telescope's wide-field planetary camera has continually provided new information on the planets, including seasonal surface variations on Mars, cloud storms on Jupiter, Saturn, and Neptune, the clearer views of distant Pluto and Charon than ever before. Hubble has also enabled unique views of the impact of the comet Shoemaker-Levy 9 into Jupiter in 1994 and provided evidence for other planetary systems in the universe. Hubble is still used now, and like I said, it's basically doubled its lifespan. It has had to be fixed, and been docked with the International Space Station for things like that. But Hubble has really provided scientists with a lot of very useful information. Okay, the next one we have are probes, are also known as flyby spacecrafts. So these guys are kind of like one and done. They're the easiest and least expensive missions to other planetary bodies were those in which the spacecraft hit or just missed. They do a flyby of the planet. Because such spacecraft spends less than a few hours near the planet and observes only a small area, the amount of information these missions send back to Earth is limited. Still, the information is richer and detailed than our Earthbound views. So these are just a few pictures of some. And basically, they're launched out into space and they send back information, but there's no intention for these guys to come back to Earth. And depending on what kind of orbit they've been put in or what their trajectory is, they might go by the same planet more than once, or they might go by multiple planets or things like that. But we get information back from them. And then, like I said, we don't intend to use them again. That's why they're called a flyby. All right, then we have our orbiters. These provide observations of a planet from an orbiting spacecraft that have two main advantages. First, the spacecraft in a polar orbit, the entire surface of the planet may be observed within a few weeks or months. Second, an orbiting spacecraft may make repeated observations of the same area, thereby recording any changes that might take place on that planet. So these guys, we shoot out to the orbit of another planet. They're also not going to come back to Earth, but they stay in orbit around that planet for a much longer period of time, unlike the flybys that I just showed you. All right, then we have landers, and these are ones that are going to land on the surface of the planet. So we have landers on Mars. Although much can be learned about the surface of a planet from orbiting a spacecraft, detailed observations must be made on the surface. That is what we can get from landers. So landers, and right now we have a new lander that is on Mars, and it is also collecting samples to later be picked up and then brought back to Earth, which is the rovers. So the rovers, so the landers land on the planets and they basically stay in place. The rovers, however, are robotic and are able to move over the surface of the planets. So a rover is a landed spacecraft that can make detailed observations of the planet's surface. However, these observations are restricted to a small area. To obtain coverage over a wider area, spacecraft can carry robots that are able to rove over the surface. Crewed missions or robotic rovers provide not only mobility, but also the capability to do complex tasks and make intelligent and selective observations. So the landers can make observations from a single location, and then the rovers have the ability to move over the surface. And like I said, the current rover that we have landed on Mars is actually able to pick up and collect samples. And the plan is for those to eventually make it back to planet Earth. All right, so we'll see you next time in the virtual science classroom, and I hope you all have a fantastic day.